India has become the first nation in the world to land on the south pole of the moon. The nation's Chandrayan-3 mission made a soft landing on the lunar surface. Making a soft landing in that region of the moon is an incredibly challenging task. That's because the lunar south pole is home to the toughest terrains and low temperatures. Permanently shadowed craters in that region haven't received sunlight for millions of years. Nations have tried to land on the South Pole but have met with failures. In April 2019, Israel's Bereshit crashed on the moon, attempting to land near the South Pole. In September 2019, India's Chandrayan-2 crash-landed on the lunar South Pole. Then, in August 2023, Russia's Luna 25, aiming for the South Pole, crashed into the moon. But India has scripted history by demonstrating a soft landing on the moon's South Pole. There are many reasons why countries are in a race to land on the lunar South Pole. Scientists believe it hosts a vast reservoir of water ice in the shadowed craters. The presence of water is of immense significance for future space exploration. It can be converted into resources such as drinking water, oxygen, and hydrogen for rocket fuel. Also, since the South Pole experiences extremely cold temperatures, anything trapped here would remain frozen in time without undergoing much change. The rocks and soils in the region could therefore provide clues to the early solar system. The moon's south pole may also contain volatiles such as methane and ammonia. These volatiles could also be used for resources for future human exploration. The region is home to the South Pole Atachan Basin, the largest impact basin on Moon. Studying it will provide insights into how our natural satellite formed and evolved. And finally, the lunar South Pole also holds significance for radio astronomy. The part of the EM spectrum below 30 MHz remains the only unexplored window in astronomy because of the significant radio interference of the Earth. Numerical simulations show that to avoid the interference, the far side of Malapert Mountain near the lunar South Pole may be a promising site for radio astronomy. The Vikram Lander will now perform science operations on the surface of the moon. The CHA-STE payload will measure the thermal conductivity and the temperature of the surface. The ILSA payload will measure the seismicity around the landing site. The Langmuir probe LP will estimate near-surface plasma density over time. The payloads over the Pragyan rover will study the mineral composition of the lunar surface. The plant life of the lander and the rover is 1 lunar day, that is 14 Earth days. After Chandrayan-3, India's next big mission is Aditya L1, expected to launch in September 2023. Aditya L1 will be the first space-based Indian mission to study the Sun. It will be placed 1.5 million km away in a halo orbit around the L1 Lagrange point. Aditya L1 will aim to solve one of the biggest solar mysteries, the corona heating problem. The problem asks why the sun's surface is at about 5900 degrees Celsius, but the corona, the uppermost layer of the sun's atmosphere, at 1,000,000 degrees Celsius.